Today I'm going to show you how to find the vertex of the parabola that comes from the function y equals ax squared plus bx plus c. What we learned so far is that the graph of a quadratic function is a parabola, and when the quadratic is in standard form, it's referred to as standard form of the parabola, which is y equals a times quantity x minus h squared plus k, that you can tell that the vertex is hk. So it's easy to identify it right off the bat. So a lot of quadratics are given to you in the form ax squared plus bx plus c. So what we showed you before was a method for taking that equation and putting it in the standard form. Okay, so what I want to do today is I'm going to show you how to just look at y equals ax squared plus bx plus c to easily determine the vertex without having to go and complete the square. To do that, what we're going to do is complete the square for this general form of the quadratic. Let's get a clean page for that. So we're going to complete the square. To do that, we're going to go ahead and start off with our standard, our general form, y equals a times x minus, that's standard form. We want the general form y equals a x squared plus bx plus c. Remember, to complete the square, the number in front of x squared, the coefficient of x squared, needs to be 1. So I need to get rid of that a, so I'll divide both sides by a. Gives us x squared plus b over ax plus c over a. Then what I'm going to do is we need to take 1/2 this coefficient of x. So take 1/2 of BA and we square it. Then we add it to both sides, remember? So the left-hand side would be y over a plus 1/2 b over a, quantity squared. That should equal to x squared plus b over ax plus 1/2 b over a squared plus c over a. The reason we do that, remember, so that we can factor this into a perfect square. So that factors into x plus 1/2 b over a, and another x, so x times x gives our x squared, plus, to get the 1/2 b over a squared, we would need this to be 1/2 b over a, and then plus c over a. I'm just going to rewrite the left-hand side. Okay. Now I want to get y all by itself. So to do that, I'm going to first subtract this term from both sides. That gives me y over a on the left. I'm going to rewrite this as a perfect square, which is x plus 1/2 b over a squared, and plus our c over a minus the 1/2 b over a squared. This over here's, keep these together. Okay, now we still need to get y all by itself, so I'm going to multiply both sides of the equation by a. When I multiply the left-hand side by a, I'm just left with y, and the right-hand side by a, multiply each term. Remember, in the standard form of the parabola, there's a times quantity x minus h squared. So I don't want to distribute the a through these terms. I want to keep that 1/2 x plus 1/2 b over a quantity squared intact. Plus, if I distribute the a through here, the second term, I get c minus a times 1/2 b over a squared. Okay, so now that's in our standard form. Remember that the standard form of the parabola is y equals a times quantity x minus h squared plus k. Well, here we have a plus instead of a minus, but what that just means is that the vertex has a negative 1/2 b over a as the x-coordinate. And then the y-coordinate is technically this, but that's kind of hard to look at and hard to memorize. So what I'll do instead to get the y-coordinate that goes with the x-coordinate negative 1/2 b over a, or negative b over 2a, is I'm going to go ahead and plug it into the formula. I'll call that then, in other words, I'm going to compute y when x is negative 1/2 b over a. And a better way to remember this is actually the x-coordinate is negative b over 2a, right? That's the same thing as negative 1/2 times b over a. And then to get the y value, we plug the negative b over 2a into the formula. Okay, so now we know what the vertex is just based on knowing what the coefficients a and b are from this original equation. Let me show you a quick example. So the vertex is negative b over 2a, right? Comma y of negative b over 2a. All right, so if my quadratic function is y equals 3 times x squared minus 2x plus 1, then a is 3, b equals negative 2. So then that means that the vertex is negative b, which is a minus minus 2, over 2 times a, so 2 times 3. And then we plug that number into the formula, so that's y of 2, 6, right, is what that comes out to be. So let me compute y of 2, 6 over here. That's going to be 3 times 2, 6 squared is 4 over 36, minus 2 times 2, 6, plus 1, which is equal to 4 over 12, minus 4, 6, plus 1, which is 1/3, minus 2/3, plus 1, which gives me negative 1/3 plus 1, which is 2/3. So the vertex is then going to be 1/3, we wrote it as 2, 6, right? And 2/3, which I could simplify to 1/3, 2/3. I hope that this now shows you how we can actually find the vertex just by being able to identify a and b from the quadratic function.